Hi, good afternoon, ladies and gentlemen. Welcome to the Mimomax Project Management webinar. This is the second webinar in a two-part series which is meant to provide an overview of a field area network deployment. In part two, we will be covering the executing, monitoring, and controlling, and then closing of a FAN project. My name is Mike Russell, and I will be your host today. I have over 30 years of experience in the telecommunications industry and have held several positions ranging from technician to market manager. I have worked for general contractors, network operators, technology innovators, and equipment manufacturers on the construction, deployment of cellular networks, fiber optic, and other types of communications networks. I've been with Mimomax for the past 3.5 years as a project manager, and I work with our key partners to facilitate the deployment of their field area networks across the country. I also work with our research and development team to bring new products and features to the marketplace. I'm pleased to have you with us today, and I hope that the presentation provides some useful insights into the fascinating world of field area networks. At this time, I would like to introduce Fabian Dellin, the General Manager of Client Services at Mimomax.
Thank you, Mike. I think we're waiting for a couple of people to join until we make a further start with that. May I suggest that maybe we wait another minute or so just to ensure that we have some other people that we are expecting to join, and then we can kick that off. Mike, I think we're gonna make a start with it. Thank you for the earlier introduction. So my name is Fabian Dellin. I'm the General Manager Client Services for Mimomax and responsible for our external facing services for our existing, new and potential customers regarding support, coverage design, training, and various other services. As Mike mentioned, we are just offering more than just equipment. We are continuously assessing the services that we offer in conjunction with our hardware solution, and yeah, we are trying to aim to feed or contribute to the customer's deployments to make their deployments as successful as possible through the services offering in conjunction with the hardware. So in today's webinar, we share with you our project management focused experience around the rollout of FAN networks. And we hope that it will give you an insight in our experience and what's all involved in the FAN network. I think we're going to swap over to the slideshow now so that we can focus on that. So as you can see here, Mimomax was founded about 14 years ago in 2007, and the founders of our company, they came out of the Advanced Wireless Research Center in Tate Communications in Christchurch. Our office is the one showing at the right bottom of it, and we've been there since the start. As our business has grown in the US and more deployments have been eventuating, we have opened up offices here in the US as well. We like to have an office close to our major multi-year deployments with some local staffing to provide support and other services as required. So the top photo on the right is our office in Phoenix, but also we've got an office in Portland, Oregon, where we've established that office about a year and a half to 2 years ago. That about Mimomax. Can I have the next slide, please, Mike? So yeah, what did we cover last time? I briefly want to go back to that on a high level for those ones that have attended the last one or that attended the last session and might have forgot a little bit about it. As you can see here on the slide, it shows an overview of the topics that we covered last time. If you missed that webinar, feel free to go to our website where you can watch the previous session that was held about a month ago. We looked at that time in regards to the project charter, what is involved in initiating the project, but also identifying the stakeholders as part of that. And we finished up in that seminar around the planning of the project. Some of those items mentioned below we'll address in the next upcoming slides before we move on to the focus in this second webinar. As we discussed in the first session a month ago, the strategic plan, the utility strategic plan, is the foundation of how a fan will be rolled out often and how the internal customers will be brought onto the fan over time. Most of the time, these projects are multi-year projects, so yeah, it's not all in one big bang. And over time, you know, it's good to have a strategy on who comes on board and how to be prepared for that. The strategic plan therefore sits at the heart of the network design, and as you will understand, the budget related to the whole fan network. In the last webinar, we looked at the list of internal customers that are, you know, need to be involved at certain stages, and they will be listed on the stakeholder register. The other thing that we discussed was the importance of the data collection. As you can see over here, the IP workshops and the RF workshops. The importance of collecting that data to help design the fan. So the first step is often to host an IP workshop to determine the data requirements for all the grid assets. And the second one is the RF workshop then that follows so that the system architecture can be defined. And then we moved on to the roadmap last time to outline, you know, I mean, what will the roadmap be from a planning perspective? So that fell into the whole planning of the project. And as you can see on the slide, the multi-year one and what comes into play. So it's clearly understood on the size and the scope of the fan in the roadmap. And now I will hand over to Mike to go do a deeper dive in actually the execution of the project, the monitoring and control, and finally the conclusion of a project. Mike, over to you for the detail on that.
Excellent. Thank you, Fabian. As you may recall, we color-coded our key tasks to red for execution, blue for monitoring and control, and green for closing the project. Today, we will be covering the final phases of the FAN project. For executing, we will be discussing topics such as IP and RF workshops, IP schema design, the RF network design, lab installation, network management system implementation, bench testing, training, base station design, base station deployment, endpoint design, endpoint deployment, and field testing. In the monitoring and controlling section, we will cover RF site surveys, base station as-builts, drive testing, RF design validation, and NMS key performance indicator monitoring. For the closing phase, we will discuss topics such as complete process documentation, transfer activities to operations, transfer RF planning to operations, transfer the NMS monitoring to the Network Operations Center, and document the lessons learned. With a high-level roadmap in place, it is time to begin the execution phase of the Project FAN. So let's break down all the activities that will occur during year one of the execution phase. As planned, the actual execution will take place in iterative phases, with the first year being the most intense. The workshops are very important as they lay the foundation for the network design, and the network design will drive what the base stations and lab will look like. We start with the IP workshop. I can't stress enough how important this work is. It is an inventory of sorts and will be the work that eventually determines the total bandwidth requirements of the network and where that bandwidth is required the most. Here we can see a list of all the information you will be aiming to collect: types and numbers of devices, packet sizes, frequency of transmission, and the latency requirement for the various devices you are connecting. It is important at this stage to ensure that all the attendees of the workshop are not only considering their device requirements today, but also looking to the future to ensure the network is designed to scale as required. With the information you collect at the end of the workshop, you will be able to create a table somewhat like this. This is an example of a customer network that we showed in part 1 of our webinar series. And you can see how useful it is to have such a definitive understanding of the network requirements. In this instance, the level of throughput required influenced our channel reuse plan across the network. It also influenced the modulation rates in the different areas of the network in order to optimize the overall network throughput. I just want to note again that in a field area network, each of these different internal customers can be assigned their own virtual local area network within the FAN to keep their traffic segregated from the data traffic of other internal customers. We do this by using Q&Q packet tagging so that the various packets can be routed to the proper VLAN and end customer. The workshops will normally last 2 to 3 days. During this time, the IP schema developed will go through several iterations as new information is gleaned from the audience. After the workshop, further refinement may be needed as new use cases are considered and developed. Questions such as, what data traffic has the highest priority, will be asked so that we can assign quality of service priorities. We will use this information to create a traffic priority list for QoS assignment. Quality of service can be manual assigned, or QoS can honor existing priority designations if they exist. After each workshop, we can then begin defining the golden configurations for each different use case that the radios will be used for. The golden configurations are easy to develop and apply. They could include use cases such as a Tier 1 base station radio configuration, a Tier 1 endpoint configuration for a metering radio, or a Tier 1 endpoint configuration for a Inteliruptor radio. For Tier 2 base station radio configurations, the Tornado and Pixis would have their own separate golden configs. Tier 2 endpoint configurations for a cap bank radio, as well as a Tier 2 endpoint configuration for a street lighting radio could also be developed. These golden configurations can be copied from a file and pasted into the command line interface of the radio. Once the network data and demands are understood, we can then begin to design the roadway that the traffic will use. The RF workshop is a working session that will typically take place over a 4-day period. The first day will normally start off with a review of the basis of design and the assumptions that were utilized for the CUP filing or the RFP reply. We will review the existing design, the coverage design methodology, the clutter data requirements, and the new requirements and inputs from the IP workshop. In between the first and second days, we will rerun the tool overnight so that we can incorporate any new requirements. On day 2, we will perform a preliminary assessment of the impact of any new requirements from day 1. From the new design, we will look to see if there are any shortfalls. If shortfalls are identified, we will seek to identify potential resolutions. These resolutions could include items such as adding additional sites or adjusting the antenna array design. Overnight, we will rerun the preliminary design with either backed off requirements or with the additional sites and antennas. On day 3, we will review the overnight design rerun and report updated design against the requirements. We would see if there are any shortfalls and establish if the design is converging on the partner's needs and requirements. If shortfalls do exist, we would decide what needs to happen to resolve or if we should back off on the requirements. We will aim to lock in the requirements, and we will also aim to lock in the sites. discuss the next steps, identify actions, and seek to establish clearly defined goals and requirements for the data. If we are not well positioned, in day 4, we will seek to resolve the remaining issues. We may require another overnight preliminary design run. On day 4, if we are converged and in agreement, we will tidy up the loose ends and prepare for the final design. If we are not converged, we will review the latest design and requirements and seek to converge and continue to drive a consensus, agreement on the requirements of the sites and such. We will also discuss the next steps, identify actions, and we will seek to end the workshop with clearly defined goals, requirements, and data. With the IP schema and RF design understood, we will have arrived at a network architecture design. A lab environment can now be created that will mirror the field environment, what the field environment will look like. With a lab installation, you will have the ability to pre-test firmware, test field devices, and test a variety of operating scenarios in a controlled environment before going into the production network. In the lab, we will seek to build a replica of the Tier 1 base station. This base station will include items such as Raspberry Pis, which will be used for running the battery management system, and a Wireshark, which will allow for live packet captures and back office analysis. We will also have the ability to test the uplink and downlink of the IP schema. Taking the time to implement the network management system at this early part of the project is key. By replicating the production environment, it will allow the teams involved to become familiar with how to monitor the network without learning the hard way on a live network. Performance monitoring and KPI thresholds can also be established. Having a fully integrated lab allows the engineering staff to test and understand how their network will operate. A lab will also allow for the maintenance personnel to become familiar with the equipment and how it will all interact. The lab is also used as a training environment for the various internal users of the fan. The final design of the Tier 1 base station can be fine-tuned based on the lessons learned in the lab. Once all of the equipment is in hand, it will only take the project engineer a day to get everything installed and another day or two to get everything up and running. It has been our experience that the cybersecurity department will need to be involved to clear a path for the data to transverse from the radios to the core network. Preliminary training is important and will generate excitement and buy-in from the internal users. The training is generally broken into several different tracks. A general overall fan overview for the internal customers, technicians, and engineering teams. A training session for fan endpoints for the internal customers, technicians, and engineering teams. A CNMS overview training session for the technicians and engineering teams. A NMS training session for the technicians, engineers, and network operations teams. And a Tier 1 and Tier 2 deployment training session for the technicians and engineering teams. Combined, these training courses can last as long as 5 weeks. Additional training on the RF design tool can also be offered for the engineer or engineers that will be working with the tool. Year 2 will be another year heavy with execution. So let's break down all the activities that will occur during year 2 of the execution phase. Most of our partners have a combination of indoor and outdoor installations. A rack layout and wiring diagram should be created for both applications. The project engineering and standards departments will typically work together to develop these drawings. For the general site design, we often see the telecom engineering department, standards department, and substation departments working together to develop the drawings. Items to be considered are base station equipment, ice bridge, and tower placement. Many of our partners try to utilize existing infrastructure, such as the pole that the AMI system operates from, as this can reduce construction costs and related permitting issues. As we begin to plan the Tier 1 base station deployment schedule, there are a few things that will need to be considered that could influence how the deployment plan is developed. Items such as business needs, ease of construction, or a cluster deployment should be considered. For business needs, we need to ask if there are any internal customers that have a time sensitivity. We should rank and order the customers with the highest needs. This deployment may have a shotgun effect across the polygon. Ease of construction should be considered. If you have a lot of new construction, there are some sites that are easier to build than others. Utilizing existing assets will create fewer zoning and permitting requirements. Constructing towers and infrastructure will add time to the schedule for zoning and permitting related issues. We should rank the sites into 4 categories and begin construction with the easiest sites in the category. Cluster deployment is preferred. This is preferred as it allows you to bring the endpoints into the network in a methodical manner. This slide represents a typical 3-sector antenna array with an outdoor base station. The base station has a redundant radio system with a DC battery backup system. The photo on the far right is a Tier 1 endpoint radio, which is mounted in a commercial solar inverter, and it's actually located inside the switchgear. It is not shown in the photo, but there is a directional antenna mounted on a pole that is attached to the switchgear. The directional antenna reports into the Tier 1 base station. Speaking of endpoints, we will also begin engineering our endpoint radios this year. As we previously mentioned, each device for each internal customer may need its own golden configuration. This golden configuration can be a custom script that will program the radio with the correct features and attributes and the proper IP networking protocols such as Q&Q VLAN tags and QoS. When engineering the endpoint devices, there are some considerations to keep in mind. We will need to rank the customers in order of need, and then begin with the customer that has the greatest need. To engineer the endpoint device, we will be working with 2 of your internal stakeholders, the internal customer and the standards department. We will need to consider how will the fan radio be integrated into the radio grid equipment, where and how will the radio be mounted, how will the radio get power, where will the antenna be mounted, how will the cabling be ran, will the radio be housed and mounted on the exterior of the primary equipment, the mounting and cable entry into the equipment. This exercise will need to take place with each internal customer for each piece of equipment. This list outlines documents that will need to be considered. These processes and procedures will be important for the various teams so that quality and consistency can be maintained throughout the fan. These will need to be living documents and may need adjusting as the processes and procedures are exercised. A Tier 1 base station installation and integration procedure could include items such as an installation checklist, a list of photos to capture, turn up and test procedures, NOC integration procedures, and document archiving requirements. I would recommend that each installation have a folder created with all the pertinent information stored in it for future reference. As the fan deploys and gets underway, there is some advanced training that can be offered. Further training for the RF engineering tool may be needed. You may also want to make changes or adjustments on the radios or data attributes so that the golden configurations can be maintained. The network management system is a very sophisticated system with many capabilities. Additional training may be desired for the technicians, engineers, and NOC teams. In year 3, we will begin deploying our Tier 1 endpoints. Endpoints for Tier 1 could include ground-mounted DFA switches, interrupters, and commercial solar inverters. When you are ready to go out and deploy a site, there are some items that you may want to consider. Do you already have the Tier 1 endpoint customer device golden configuration installed on the radio? Do you have the customer device hardware installation standards in hand? Do you have the 5 best server information in hand so you can connect the endpoint to the network? Do you have the Tier 1 endpoint network integration process controls and procedures in hand? Is the NOC aware that a radio will be integrated into the network today? We will install the radio and the antenna equipment, connect the radio tier to a Tier 1 base station via RF link, integrate the radio into the network with the NOC, confirm that the network management system recognizes the equipment and the link, and confirm that the KPIs are within tolerance. Record the information and then mobilize to the next site. We are now in the home stretch of the execution phase. In year 4, the final BTS Tier 1 base stations are integrated and installed. Tier 1 endpoints continue in a business as usual manner for the next several years, and additional Tier 1 endpoints are designed and deployed in a business as usual manner for the next several years. In year 5, it is expected that in a project of this duration, some team members may move to other parts of the organization. Additional training can be provided for new personnel. Assessments and touch-up training can be provided on an as-needed basis. We'll now move to the monitoring and controlling phase of the project management plan. Monitoring and controlling the project will begin in year 2. We will create a feedback loop with a radio site survey and redline implementation. This feedback loop will provide quality and design validation. Often, the Tier 1 base station locations were chosen based on which ones would provide the optimal performance from an RF engineering perspective. These locations are often picked from a list of assets with some basic assumptions and constraints. It is recommended that a radio site survey be performed so that any potential problems can be identified, and if need be, a different site selected. The radio site survey is broken down into 2 sections. A physical survey will validate assumptions such as antenna heights and equipment placement, as well as identify any physical limitations such as trees. A radio spectrum survey will provide information about the existing noise level on the site. If a site is deemed unsuitable for any reason, an alternate site will be selected and another radio site survey performed, and the RF design will be updated accordingly. In some cases, there are changes that are made in the field during the construction process. Any changes to the antenna height, down tilt, azimuth, cable sizes, cable lengths should be accounted for. The RF design tool needs to be as up-to-date as possible so that it can be accurate. In year 3, we will perform our first network validation drive test. RF coverage design validation in the early stages of the deployment is important so that we can validate the RF model that was used to design the network. Variances between the RF model and field results need to be understood so that the model can be updated. Updating the RF model is important for future evaluations. The FAN is not a mobile network. As such, we need to pick roads that will allow for a slower driving speed through the different types of terrain. Each morning, a system and calibration test will be performed to ensure that accurate data is collected. At the end of each day, the data is downloaded and transferred to the person performing the post-processing. The drive routes are pre-planned and approved by our partner. This slide shows 6 major drive routes. After the post-processing has been completed, the data collected will be imported into the RF design tool. The RF design will then be reran. The field results can then be compared to the RF design model to verify that the design coverage is still being achieved. We will seek to answer questions such as, is the expected site footprint being achieved? Is the site over or under propagating? Is the desired signal level being achieved? The newly updated model will allow additional refinement to future predictions. In years 4 and 5, the monitoring and controlling will continue in an iterative fashion. In year 4, the final Tier 1 base station constructions will be complete and the red lines will be incorporated into the RF design tool. Data from the Tier 1 endpoints can also be incorporated into the RF design tool to help improve accuracy. The RF design needs to be kept up to date as possible so that future predictions are accurate. In year 5, the final performance drive test can be completed after the last Tier 1 base station has gone on air. The final comparison of the drive test results versus the network design can be completed. The drive test data will be incorporated into the RF network design tool for the last design update. The RF network design tool and associated data will be made ready for turnover to the operations team. The moment we have all been working towards is finally upon us, closing the project. In year 4, we can begin some of the closeout processes, such as the Tier 1 base station deployment. To keep the design tool as accurate as possible, make sure that the last of the construction red lines have been incorporated. As I previously mentioned, it is recommended that each installation and Tier 1 base station have its own folder containing construction drawings, red lines, photos, installation checklists, and other such items. Having complete files and information is extremely important for the archiving process. In many organizations, the staff rotate or are assigned to different projects. Leaving clear documentation is required so that the next person doesn't have to reinvent the wheel. In year 2, we started documenting the FAN processes and procedures. Make sure that the Tier 1 base station design and installation processes are still valid. Some of the items may have changed throughout the installation period. These documents will play an important role if additional Tier 1 base stations need to be deployed in the future. As we discussed, Tier 1 base stations may need to be added to the network due to traffic congestion or territory expansion. Make sure that the Tier 1 base station expansion process is still valid. It is important to leave a trail of breadcrumbs for those who follow. We are now going into the home stretch. From a project management perspective, much of your time in year 5 will revolve around closing the project and transferring ownership to operations. The RF design tool will be used for any future base station expansion projects. It will also be utilized for any new endpoint radio implementations. It will also be used if any point-to-point path studies are required. Using the design tool, predicted versus actual results to be compared for troubleshooting and future link designs. The operations department will need to keep the tool up to date by incorporating Tier 1 endpoint information and as-built information. The operations department will need to use this tool if future base stations are required, and a formal handover of the tool should take place. As the project winds down, activities need to be transitioned to the operations team prior to losing the personnel that were performing the work. There will need to be a transfer of ownership of the network management system to the Network Operations Center. The NMS is the primary tool used to monitor the health of the network. The NOC may also need to be involved with the Tier 1 endpoints that are being deployed to ensure that they are displayed and operating as specified. Transfer of the Tier 1 endpoint deployment process to the operations team. A handoff needs to be performed so that the operations team has a full understanding of the network and activities. Each partner has their own unique way of closing a project. Make sure you understand the company's policies and procedures around closing a project. It is the project manager's duty to ensure that all the applicable processes and procedures are followed and the proper sign-offs are achieved. The fan you have designed and built is a unique system within the utility's operations. We did not discuss this, but lessons learned meetings should have been held throughout each phase and major milestone. A final lessons learned meeting will be needed to document the final pros and cons of the project. After this final meeting, all the project lessons will be transferred into the master lessons learned log. With such a lengthy and complex project now being completed, a celebration is in order. If possible, all the personnel that have taken part in the fan should be invited to a celebration event. From the time of the original business analysis and project charter to the final turnover to operations, many people would have taken part in the fan, and they should be recognized for their efforts, contributions, and achievements. Fabian, back over to you for any questions. Thank you.
Mike, thank you very much for the level of detail that you've outlined, what's all involved in the project management of the fan network. Just wanted to outline, as Mark I went over a lot of items that are involved in the rollout of a fan network. There's a lot of steps involved where we can help customers with, as Mark touched on, the commissioning side of things, project management, documentation, but also training and potentially a capacity analysis. Once you start understanding how your network is utilized. So just want to let everybody know that is on the call that if there is any need for these kind of services that Mimomax will be able to offer or think with a customer on how to resolve certain kind of challenges from either a technical or a resourcing side point of view on. So yeah, questions, good point. Let me have a look at the chat and everything like that. So one of the questions that is coming through for the IP schema workshop, which are the key roles from our utilities that will need to be there? So what key roles from the utility point of view need to be there, Mike?
With each internal customer, the person that knows the equipment requirements the best, as well as many of our partners have a IP network engineer that is involved with the fan. So that network IP engineer, along with the different internal customers, would need to be involved in that IP workshop.
Okay. Another question that came through is when your customers have lab installations in the past, how long does the equipment need to be connected for testing? So is that just a couple of days or weeks, or how does it, how does it sit in the process?
That actually varies quite a bit with what you're trying to accomplish. We've seen some internal customers that bring their equipment into the lab, and in about a day, they complete all of their testing. Sometimes there's additional firewalls that need to have paths created for the data to transfer through, especially when it's a new customer with a new VLAN. We need to make sure that the data is transferring from the equipment through the radio network, and then through the fiber backhaul network into the final head end. So normally it's about a day. In some cases, we see people leave their equipment in the lab for a week or two to run cycle testing. But I would say generally most of the equipment is only in there for 1 or 2 days.
Okay. At the RF workshop stage, is that normally something the utility does on their own, or do you, does Mimomax usually have staff there to help with it?
We have found it beneficial to have our staff at the workshop. In the past, we have had a person there to facilitate and guide the workshop through the various stages. And then we also have our RF network design engineer there to help answer questions and clarify any points that the partner might have. And then as we mentioned, often in between, from the time that the workshop breaks up one day till the time it resumes the following morning, we will rerun the plan, the tool, with the new information, so that the next morning we have a fresh set of data and results to take a look at. So we do normally have a couple of people there at the workshop.
That makes sense. In your experience, how as a project manager do you prevent, any internal tensions between departments when priority is given to certain business units over others during the base station construction?
Luckily for me, most of that is taken care of by our partners PM, who is very instrumental in the entire process. Unfortunately, from time to time, there are some tensions that occur, and the partner PM is very instrumental in diffusing those tensions. But quite honestly, most of the time, it comes down to the business priority. As we mentioned, it's the who has the greatest need first, and often that's identified in the strategic plan that we took a look at in the very beginning. We did have one customer who their metering department was using a network that was going through, and the communications network was going through a sunsetting phase. And in this case, we did prioritize them, and we built tier 1 base stations which they could offload that data to. Once those tier 1 base stations were constructed, then we went through and we finished deploying those base stations in a methodical manner. With the endpoints, once the base stations are built, the endpoints can then be deployed, and quite often it's a matter of how quickly and how much personnel does the partner have available to deploy those endpoints. And again, that's often done according to the business plan and the strategic plan.
Okay. One other question is more around the documentation side of things. Do we as a utility have to document all these processes and procedures that you refer to ourselves, or is that something that the vendor usually provides?
We've seen some of both. In some cases, we provide the documentation as a service. We do this because each partner is a little bit different and each network is unique. We do recommend that a comprehensive set of processes and procedures be created so that quality can be built into the network and the network maintained.
All right, and I think I've got one last question over here. How long should we expect to allocate for post-processing of the drive test data, and which department is normally responsible for that activity?
Mimomax will post-process the data. As we mentioned, at the end of each day, the data is transferred to the Mimomax person who will be doing the post-processing, so that we can start the process as expeditiously as possible. It will generally take about a week for all the post-processing to occur. And after that time period, it will take some additional time to understand the data and import the data into the RF design tool. Once the data is imported into the RF design tool, we then rerun the tool with that new data so that we can compare the predicted results with the actual results. Once we've done that, then we'll generally prepare a report and then also a presentation so that we can display the information to our partner in a methodical manner. Generally speaking, from the time the drive testing is complete till the time we give that final presentation, I would say is about 3 weeks.
Okay. Thank you for answering those questions, Mark. That's really appreciated, and of course for the webinar overall to give the attendees an insight on what's all involved around the project management of a fan rollout, and in particular the execution, monitoring, and control and closing stages of that. I just want to remind all the attendees that we've got a handout in the session that can be found, I think, on the right-hand side for everybody under the drop-down box of handouts. So feel free to download that. Again, this recording, if I'm correct, will be posted on our website. So if anybody has missed it within your organization, they should be able to go to that at a later stage to bring that back up. And yeah, I would like to thank everybody for their attendance. And if there's, as I said before, if there's any need for any assistance or any feedback, we would like to hear that from anybody who attended this webinar. Thank you very much and have a nice day.
Thank you.